distribution analysis and data visualization as a part 2 of our statistics. For that we can use histogram for examining distribution shape. As you know, we already done this task, and now let's try to do part 2 of that. For that we need to import Matplotlib and Seaborn. We already done that. So for that, let's try to plt.figure. We don't need to write every time our libraries import. We don't need to do that. So which size is equal to, let's make it by 8 and 5. After that, sns dot hist plot and df. In that we have to add average time, screen time. So we have the average screen time here. Let's check where we have. So we have this. So just copy that, paste here. We have bins is equal to 20, kde is equal to true, color is equal to blue, and close this. plt.xlabel. So for that, screen time hours. plt.ylabel. Frequency. plt.title. We will give the title here, that distribution of screen time, and then we showed our plot plt dot. As you can see, we have the average screen time and count. So this was the histogram for examining distribution shape, and which is one of the best tools to visualize the spread of data. It shows the frequency of different screen time values and help us to understand whether the data is normally distributed or multimodal. So as an interpretation, if the histogram is bell-shaped, the data follows a normal distribution. If it is screwed to the right, more people have lower screen time, but the few have high screen time. If the screwed to the left, the majority have the higher screen time. As we can see, if there are multiple peaks, the dataset may contain different groups, like students versus working professionals. So let's create a box plot which will detecting the outliers. Because it's very useful tool. Box plot is a powerful visualization tools that which will help us to identify outliers and data spread. And it is also shows the minimum and first quarter, like Q2 and Q3, and also maximum values. So let's create a box plot for that. So for plt dot figure, in that fit size is equal to 6 and 4. Also SNS we are using the Seaborn here. So y is equal to df, and in that average screen time, we know we have hours, and close this parenthesis, and color is equal to green, and also plt dot title, that box plot of screen time, plt dot y label, that I want to add screen time hours, also plt dot so we'll get the output here. As you can see, we have the closing parenthesis syntax error, and what is the problem here, that as you can see we have the, okay, this is, okay, we have to add this, and now we can run this code. We have the syntax error. Okay, so invalid RGBA green. Okay, so we made one spelling mistake here. As you can see, we have the y label screen time. Okay, so these are the, like, this is the box plot of screen time. Visual interpretation, I would say the box represent the interquartile range, which is 50% of the data middle. The line inside the box is the medium Q2, which divides the dataset into the two equally, and the outliers are represented by the individual points beyond the whiskers. If the box plot shows many outliers on the, like, higher side, it means that some users have extremely high screen times compared to others. This might indicate the, like, exclusive usage of or errors in data collection. So I would say key interpreting key insights, that now that we have visualized the dataset using the descriptive statistics and visualization, what can we conclude that? So first of all, we have some questions, that what is the average screen time? The mean and median will help us to understand how much time, or on average, people spend on their screens. If the mean, as you can see, we have the this plot. Uh, if the mean is slightly higher than the median, it indicates the presence of outliers with very high screen time. And the second question would be, there are any outlier in screen time usage? So if the box plot has many points beyond the whiskers, it means that some users spend significantly more time on the screens than others.